So today we're going to try to finish up modeling exponential and logarithmic functions, kind of seeing the difference between, pay attention, seeing the difference between exponential functions, linear functions, quadratic functions, whether it be graphically or in a table or writing equations about them. You have a lot of experience with the linear and the quadratic. We're going to kind of deal with the exponential and log as well there. Okay? So the first thing I want to do is take a look at your extra practice, page 187 of your student journal. I just want to kind of review a couple things with you. We're only going to do one page of the extra practice. We're not going to do page 188. Okay? It says, in example or exercises 1 and 2, determine the type of function represented by the table and explain your reasoning. I want you to spend time on 1 and 2, just a couple minutes with your groupie talking about information we've done in the past that might help you out there and what we've done this chapter to help you out. Okay, what do you guys think about number 1? How do we know it's quadratic? Yeah. Good. Rachel, what was that called? Yeah, the second differences. Yeah, the second differences are constant, therefore it's quadratic. Remember, that only works if your x values are constant as well. Okay? Second differences are constant. So you find the difference and then find the second difference. If it's true, it's quadratic. How about number 2? How about you focus on the top? What's happening? Yeah, you're multiplying by 3 every time. What type of pattern is that? It's true. It is moving by 2 on x. However, it's still an exponential function. So you're going up by 2, which means you're really multiplying. Like here, we can just see a common ratio of 3. If we were going up by 1, really you'd have to take the square root of 3. Okay? Yeah. Because you're not adding a constant amount. Linear would mean you're adding 2/5 here, so you'd have to add 2/5 here, which you're not. You're adding 4/5. Okay. So exponential has a common ratio of 3. And remember, the way to find a common ratio, just take this and divide it by that. Take that, divide it by that. That divided by that. Okay? In this case, that gets 3 every time. You get 3. Now, if you're writing your equation for this, our b term would not be 3. As Walsh said, you're going up by 2 up here, so we'd have to change what our b term is, okay, which we'll actually see in the next set of problems. Okay, so remember, quadratic, second differences. Linear would be first differences. Would be constant. Okay? Exponential, you have a common ratio when you're dealing in table format. All right, I want to take a look at 3 through 6. Okay, let's focus in on 3, actually. Write an exponential function in the form y equals abx whose graph passes through those points. Okay, go ahead and work through 3 with your groupies there. Best you can. Any thoughts? Pat, you had a thought? Oh, me no? That's quite a thought. Oh, me no. Like acid? Huh. Way to be thinking. Man. All right. How about if we did this? Well, first let's focus in on a few things. What is A? A is your y-intercept. Okay? It's when x equals 0. What is B? Rate of change, so growth or decay. Thank you. All right. So if we focus in on those 2 pieces, because it says write our function in y equals abx, okay, whose graph passes through those points, well, they give us 2xy values. Now, if one of those x values happen to be 0, that'd be great because they'd also give us a then. However, I'm looking at all these problems and none of those x values are 0. That was probably on purpose. So x and y. We do know that that's 1, and that's 12, and 3, and I'm going to skip. I'm going to actually put 2 in there. 3 and 108. Now, you guys, this previous problem up above here, we dealt with a table, and we found that it was exponential because we multiplied by a constant amount. So if it's exponential, which it is, they tell us that, then that means from here to here, I am multiplying by 9, and that means every time I skip 2, like if I were to skip to 5, I would actually go times 9 again, correct? So what am I doing if I want to just go one step?
Times 3.
Yeah, times 3. I take the square root of that, right? Because if I multiply by, not 3 there, times 3, that gives me 36. And then if I were to multiply 36 by 3, I'd end up at 108. So by being able to do that and follow that pattern, I've just found what term? Come on, which one, A or B? I found B. So B is 3. How could I find A? Tell your neighbor how you can find A.
Plug in the number. Plug in the points.
Okay, so I can personally see two different ways. I can actually see a few different ways to find B, but two specific ways I'd hope you would see from here. What's one of those ways? Rory? Yeah, I could just work backwards, right? If I work backwards and say, okay, I want to find 0, that means I just have to divide by 3 and I get 4. A is 4. That's one way. Probably the quicker way in this one. What's the other way? Use an equation to do it. Rachel kept saying it, like over and over.
I didn't know what the numbers were. I didn't remember the words.
If you know A and B, or excuse me, if you know an XY value and you know B, you can plug all of those pieces in. Just pick one of your XYs. That's 1 and that's 12. And solve for A. That's the other way to do it. Right? I mean, you only have one variable. Either way, you find out that A is 4, B is 3. Therefore, my equation is y equals 4 times 3 to the x. Little pencil tapper girl. All right. There we go. Yeah. You mean if that would be a little more complex to see. That's right now they're just having you go through here. So technically you could say that this is doing that, but because they're telling you this pattern, that you can't find that out there. Yeah, that's a really good question. Yeah. Okay, I want you guys to try number 4. Okay, here we go. Hey, on this one, there's my table. Hey, please note that they gave us -1, 2, 3, and 32. You're going times 16, and notice that there's like 1, 2, 3, 4 steps from there. So if I am going times 16, really to find what I'm multiplying here, I need to take the 4th root of 16 to figure out what one of those steps would be. The 4th root of 16 happens to be 2. Therefore, I'm multiplying by 2 to get here. And you can check that. I mean, double that, you get 8. Okay? So you go times 2 is 8. Times 2 more is 16. Times 2 more is 32. So your A term happens to be happens to show up in the table now, that's 4. Your b term is 2, so you have y equals 4 times 2 to the power of x. Pretty cool, huh? Questions? Okay, one last piece here today. I want you to take this table right here, and I want you to put it into the stat menu of your calculator, please. Stat edit of your graphing calculator. If you click stat and you have other things in, go up to the top where it says list and hit clear so you can clear them out. Good job.
Mr. McCoy, have you ever heard of the song 99 Red Balloons? Your awards. What?
Old school song. Okay, ladies and gentlemen, up here. So once you're in there, hey, eyes and ears here, please. Okay, you put your lists in. We hit quit. I want you to go to find the exponential model for this data using exponential regression. Okay? Exponential regression. Remember, your regressions are under our stat, calc. We are calculating not linear regression like we did earlier in the year, quadratic, or cubic, or quartic. We keep going, and we get, notice we have natural log regression, we have exponential, we have power. Okay, we want exponential regression. We hit enter. List 1 is where we put our lists. List 2 is where we put our Y list. And we hit calculate, and there is our exponential regression. Remember, R squared tells you how close it matches up. The closer that is to 1, the better it matches. Yes? R again, does anyone remember? Hey guys, I'm not going to be mean about it, but I have told you this like 3 times this year. So, you might, I don't know who you'll have as a teacher next year or if they'll tell you it. So write it down somewhere. Okay? You go to catalog, second 0. If your R squared's not showing up, second 0. Okay, notice the little alpha thing is on because that little A is showing up in the corner. So you want to go to diagnostic on. So if you find the letter D on your keyboard, which is right here where it says matrix and next to the negative first, and go down to where it says diagnostic on. Hit enter, and it'll say done. Now when you do that exponential, you should see the R squared. Okay? All right. Very good. One more problem while I'm going to put up that while I am handing out your assignment. There it is. I realize there are lots of words. It's okay. You can read the words. I will tell you part that is a little confusing is this is an actual, that's your actual function that you're trying to make. Okay? Okay, once you have your table in there, it's stat. Which one now?
No.
Not linear. Natural log, right?
Natural log regression.
Okay, so there's our our A, so H is equal to 0.86 if we round to the nearest hundredths, plus our B, negative 6.45, ln 2, in this case, P. Which is P, this one? What do they tell us our pressure needs to be? Yeah, in this case, they're telling us it's 0.75, right? So the model would just be P, but when you're actually making that prediction, you would have H equals 0.86 plus, you'd actually put minus there, minus 6.45, natural log of 0.75. Walsh, you said there need to be parentheses somewhere?
Would there not have to, okay, I guess not anymore. Yeah, not anymore. Just in the first one, you wrote it 0.86 plus and then negative 6.25, and it was just kind of weird.
Oh, yeah. Yeah, that's why, yeah, I got rid of it there. Okay? Good, so if we actually calculate the height, or the altitude, in this case, would be 2.72. Good. Kilometers. You guys, I guess those of you that wrote it like this to begin with would probably be more accurate. Put that actually ln of P right there, because that's more the general form. Well done. How many got it? All right. Any questions?